So we'll now discuss of a spurious relationship for two non-stationary time series variable. So we already have opened our Stata and we have generated some random variables here. What we can see, we have the variables, time variables and stock price index for one for commodity one and stock price index for two for commodity index two, and we can see the RW1 is for the time series variable and RW2 is another time series variable. So let us check the graphical presentation of these two time series variables. So what we can do, we can plot the graphical presentation as two-way line for RW1 and in respect to time. So what we can see, this is the visual inspection. What we can see, the the trend, the movement is not going towards a specific value. So this is how we can say this is a non-stationary time series. Similarly, we can check for the stock index 2, and then we also can see this is another non-stationary series variables. So we also can check the graphic visual presentation for both of these variables, and what we can write two-way and line and then variable name with respect to time, and then another line for variable 2, I mean like stock index 2 and against time. So this is how we can compile both of these two graphs in one graph, and we can see the green blue color one is the stock price index for stock index 1, and the maroon color one is for the stock index 2. So in the previous session, we have visually inspect whether the series are stationary or not. And we found both of the stock indices are non-stationary. Now we are going to empirically test whether the series are stationary or not, and then we will discuss how spurious regression will occur if non-stationary time series variable exist. So to check the unit truth problem in our time series variable, we mostly use the augmented decoupleur test. So for that, if we remember, we first need to uh, we first need to select the appropriate lag for the unit truth test. So to check the appropriate lag for the unit truth test, what we do, we just write var SOC. Uh, this is the function for which variable we want for the stock index 1. So RW1. What we can see, uh, what we usually do, we usually select the lag order based on the standard information criteria, and most of the studies follows the AIC criteria depending on the minimum value of the AIC. So what we can see that when the lag is 1, the AIC gives us the minimum value, therefore we can say the optimal lag is 1. So then we can do the Dickey-Fuller test. To do the Dickey-Fuller test, what we need to do, we need to write the D-Fuller function for RW1 variable, and we saw that there is a trend for the equation for the graph, and we have one leg optimal and we are regressing. So this is the command, and we have seen that this is the test statistics. So to check the Dickey-Fuller test, we mostly use the tau test, where the calculated tau is lower than any of the critical tau. Therefore, we can say that the series is not an stationary series. So similarly, we can check the optimal lag order for variable 2 using the same function, and we still can see that it has lag of 1. So therefore, the optimal lag is 1 because it has minimum AIC criteria. So now we are going to use the Fuller function for variable 2, I mean stock index 2, and check the Fuller test. Still, we can see that the tau test statistics is lower than the critical value. Therefore, we can say that has a non-stationary problem. So we have shown that both of the stock indices have non-stationary issues. In this case, if we regress, what we can see, if we regress both the equation, we can see that the coefficient is statistically significant at 10%. Although our graphical analysis shows that they did not have any kind of relation. It seems that the stock index 1 going down where the stock index 2 going up. Again, so they shows the random behavior, but in our regression, what we can see that stock index 2 causes to decrease stock index 1. So this is how we we can see, this is how we might accept a false hypothesis. So in the graphical or visual presentation, we see that both of the series are non-stationary, as well as in the visual presentation, we can see that both of the series may not affect each other, right? So, but whenever we make the regression for two non-stationary series, we can see that we can reject the null hypothesis. That means that stock index 2 has a negative impact on stock index 1, but which is not true. So this is how, when we use a non-stationary time series uh, for our regression analysis, it might lead to a meaningless uh, estimates as well as. So this is how, when we use non-stationary variables in our regression model, it would offer us a spurious relation or a meaningless relation. Therefore, we cannot use a non-stationary time series model in our regression analysis.